You don't need to tell her that.
Afternoon. How are we doing today?
Afternoon, sir.
Nice. How are we doing today? Good?
Yes, sir.
Nice. All right, I'm just waiting for another couple of minutes for the ones to join, to come in. There are only 6 of you here. So just give me a few more minutes. Everybody here has completed the few questions I gave.
Yes, sir.
Yes, sir.
Yes. Charlene, I don't know what I'm doing, you know, Charlene. Charlene, why don't you hear yourself, Charlene?
Sir, I got 2 questions again.
Yeah, me know, but Charlene, make care of the people them say, Charlene.
Sir, look how long we had class.
No, man, Charlene, they play rough. Me would have cried cree. But, you know, I'm really happy. And when I saw this stuff, I was very encouraged. Encouraged that at least, you know, you guys are with it. You know what? Let me not hold you at ransom. I really am very encouraged to know that you guys did what it is that we're supposed to do. Let me go through those questions.
Sir, I have one make a stupid question for asking.
And guess what?
When you start,
no question is stupid. No question is stupid.
I just want to get it in my head. I have it in about in a concrete yet. I want to get it concrete.
All right, Calvito. Shoot. What seems to be the problem?
Sorry, I have to bring up with notes paper.
What's your I like how you put it in now. We notes paper.
Yes, we know it's paper.
Yeah, never mind. I'll do it. I'm at your service. At your service. Art is coming up. So let me just yeah, man. I'm very encouraged. When I say encouraged, guys, it I love to see when students can work and all when Charlene is roughing them up, but at least it set them straight that look how long sir you get to the question or upon do it, which is true. So I agree with Charlene, right? But love it. I love the camaraderie and I love the level that of dedication that it takes to the math class. And I couldn't ask for anything better. And I also need to get a little feedback from you guys, how this thing has gone so far, what we can do different. I don't want to be stuck to one style and that style is not working for somebody. So you need to talk to me too. All right, so Kelvito, I am right here. Let me do this. This was the example I did in class.
Yes, sir. Stay right there, so. So, I want to get this negative and positive.
Which negative and positive? This negative and
yes,
this positive? Okay.
Yes.
The negative
so,
to the left.
Yeah, to the left and to the right.
Turn to the right.
No, in my little brain box, me see it that way and tell me if me wrong. So when the mouth of the Pac-Man is open. When the mouth of the Pac-Man is open, it is going to be negative. And when the mouth of the Pac-Man is closed, it's going to be on the positive side.
Right. So I've never taught it like that. And I'm going to tell you something, Kelvito. When I have students come to my class, when I used to teach 6A math, and the students come to my class and tell me, say them teacher, show them on something, open this, that, I get very annoyed in the classroom.
Okay.
Because it's based on what it is that you are saying to me. It could be either of the two of them.
Okay.
So let me just show you something. And when I show you, just tell me whether or not it has cleared up your confusion. Because guess what? It is, you're not the first. All right. So forgive me though. You asked a question, and I need to make a notation because I don't take your questions for granted. So that line. So if I do this, and I do this, and I do this, and I say. It's no, I don't want that. So it's a little bit. Right. I'm coming to it. I'm just trying to copy. I'm going to paste you here. So watch me now. Let me just take it in stages based on what it is that you asked. So yes. So the first thing here, when I say x tends to -2 to the minus here, it means that x tends to -2 to the left. So it means that x tends to the left of -2 and x tends to the right of -2. So the plus sign is to the right and the minus sign is to the left. And it follows from here.
Hold on there, sir. You have one black screen in front. All right, come off now.
Okay. So I'm saying to the left means less than and the right means greater than. So the right is going to be positive. See it here? Right is plus VE positive. Minus VE negative. So what I'm saying to you is to the left is less than, and we use it as a negative sign. See it right here, so because that's the left. So let me just put this here to show you. And I can take off the underline right here, so, and again, take off the underline right here, so, and again, put this as uppercase. And the right means greater than, and it is positive. All right? Okay, so these are two additional stuff that I put in there to increase your understanding of what it is that we are supposed to be doing or what is expected of us. All right? Now,
okay, sir.
Yes. Kelvita, watch me now. It's because we read in this neck of the wood. In this neck of the woods, we read from the left to the right. Do you agree with that?
Yes, sir.
Sometimes I wonder how them other places, how them read from right to left. I think that's a reading. But we read from the left to the right. So this is what I want you to get. So because we read from left to right and not from right to left, from left to right, if when you're reading from left and you see this thing open up, it means that it is greater than. When you're reading it from the left, so our starting point is going to be the left. When you're reading from the left and you see it close up, you don't open up to it, it opens away from it, it is less than. Does that help you?
Yes, sir. Thank you very much.
You sure?
Yes, sir.
All right. Let me just put something else here.
Sir, please read number 4.
All right, I soon read it because number 4 mix up. Number 4 mix up, so I soon read it. What should I write, Lord? Help me. So since we move from the left to right, once the input is in, opens. So since we read from the left to the right, once the image color sign opens to you, then it is greater than. Otherwise, it is less than. All right, so and I will read up this over sometime later on before I send off this thing to you and make further adjustments. So let us go again just to concretize this fact. So remember, in this neck of the woods, we read from left to right. We read from left to right. So here we're reading, but it opens up while we're reading from left. See, I'm moving from left, and it opens up. That means it's greater than. I said, otherwise it is less than. When I'm reading, and it closes and opens the other way, that means it is going to be less than. So once it opens up to you while you're reading from left to right, then it is greater than. So some people say to you that the mouth of the alligator here is open. The mouth of the alligator is open. So it is greater than. And others will say to you that the mouth of the alligator is closed. All right.
Sir, thank you very much for my notes. I deserve a shrimp meal.
Oh, geez, curry lobster even. All right. So in
Sir,
other
push it, the packet down, for the shrimp.
I hear you. In other words, the mouth of the alligator is like so. The mouth is low. Like so. All right. Okay. Now your other question, no. I answered the two because I put in these two to mean left and right, and I explained that. Okay, good. So Kelvin, okay. No, I got another question. Sir, read number 4. Not a problem. Pleasure is mine. Number 4 says, so when you have a combined inequality, you have to read from the inside out. You have to read from the inside out. You have to read from the inside out. So what you're going to be doing is to say x. So you're starting at x. X, watch me now. Because we're reading inside out, and I'm starting here, that means I'm going to read away here, and then I'm going to come back here so, and then I'm going to read away here so. But you see, because I'm starting here, and while I'm going so, the mouth of the Pac-Man or the alligator open, that means that part is greater than. So x is greater than -2, all right? But when we start from here so, I'm going to read go so, the mouth of the something close, but it have an equal sign. So it is going to be less than or equal to. All right. So remember, wherever we're reading from, so we read from left to right. And there's a reason for me to write this thing down here, we're reading from left to right. Because what is this sign here?
-5?
No. Don't want to read something upon.
Equal
sign. It's like equal sign. All right. The equal sign can be read both ways. So a lot of people, and I was guilty of it too. When we go look at school teacher, right? X is equal to 2. P is equals to 5, Z is equals to 1, Q is equals to 0, right? But guess what now? When me start teach, I mean write 2 is equals to A. My students, CXC students in the system say, sir, it's wrong. You can't write 2 is equals to A, sir. A is equals to 2. And I found it to be very interesting because your inequality, your inequation signs can be read both ways. Both ways. So that's why I was very cautious in answering Kelvito. And that's why I said to you, since we read from left to right, now this piece here is important because look at what is happening here. So if we can read from right to left, the greater than sign is not going to be less than. This will not be less than because when I reading from right over to left, and I come so I'm going to meet the mouth of the alligator is closed. So this can be less than. And when I'm reading from right to left, it opens, so it can be greater than. So the inequality signs can be read from left to right or from right to left. But when you get a single inequality, like what we have here, and because we're reading from this left to this right, it means that this sign is less than. And because we're reading from this side to this side, it means that this sign is going to be greater than because it's open towards where you're reading. But when we're reading the inequality sign, the double inequation sign or the combined inequation sign, we always start from the middle and read to the left and the middle and read to the right. So this concept that I'm telling you about here is wherever you're reading from, that's what happens. That's where you're going to read the stuff. So look here. Bam. And I'm going to the left. So I'm reading. See the mouth of the alligator open. So this is going to be X is greater than -2. I'm going to write that down. Bam. I'm going to go to the right now. X, the mouth of the alligator is closed. So X is less than or equals to 2. All right? So just be careful of that. Some people read this as -2 is less than X, which is less than -2. Nah, that don't make no sense. Right? This is a combined inequality. And the combined inequality is read a specific way. It's read a specific way. We read it inside out. Just remember that. Inside out. Once you remember the inside out saga, you're good to go. Really, really good to go. Okay. So question. Is this clear now? Is there anybody else that has a question relating to this? I would say to you, I have some housekeeping matters to deal with you here, guys. But I would say to you that I really appreciate the questions that came at the start of the session. What it says to me is that there are students who are doing work, came across something that they are uncomfortable with, and at the start of the class, you put it on the table, and that's excellent. Excellent. I'm going to say something, and I really want this thing to happen. So far, my pass rate for the calculus courses are very good. And I'm really hoping and praying that for those of you who are not grasping as best as you should, and guess what? Believe it or not, you may not verbalize it to me, but I've been a teacher for many years. Many years. And why am I still seeing new students in my class? No. You need to have a chat. I come in the class and I don't even say, oh, this, sir.
Sir, you need to check your chat. Somebody asking a question, Yannick.
Sure. No one. Who is this Nigel Mason person? Nigel.
Good evening, all.
Yeah. How may I help you, Nigel?
First day in this class, sir.
You're the first day in this class. And you just come sneaking from the teachers and don't even yell up the teacher, Nigel.
Actually, you were in the middle of a session. You were in the middle of teaching. I could not disturb you like that.
Okay, but you know, you could have disturbed him by dropping something in the chat. Right,
Actually,
so,
because I was late, I was just
okay, trying to catch you.
Sorry about that. Yeah,
Yeah, man. Easy, Papa.
Firstly,
Yeah,
sir.
yeah. The point I'm trying to make, Don Angel, is that I finished Unit 1 already. You have a whole lot of work to do, sir. But we said that when you add a little more, we're going to start to the future then. Yeah, yes, Yanni, something like so. Let me read it again before we say yes again. Sorry. Alligator mode, open to the term that you start. Yeah, man. It's the same thing I said, Yanni. Very good. Very good. All right. What's your name again? Yes, Nigel. We have a lot of work. I am actually finished with Unit 1. I am just going to go through some piecewise functions and do some past paper questions. So you have a lot of work to do for me. But the point I'm making though is it is important, students, for you to hold on. Yeah. Yes, please.
Oh, I as a ringtone, sir. Every time you hear that ringtone, just know it's an old person, you know.
I'm Charlene. Charlene, take him off on the please, Charlene, please.
Baby Chef, baby Chef, love sir.
Charlene, take him on for me, please. Charlene, I will forgive him, you know, Charlene, but take him on, Charlene. Charlene, finish him for me in the chat.
Sir, I'm gonna deal with him later.
Thank you very much, Charlie. Thank you very much, Ryan. I forgive you. All right. Yeah, man. So what I really want you guys to do is just participate. I want you to participate in class, and the more you participate and the more you ask me questions and you interact in it. I don't want a spectator in the class. Let me see if my spectator is here. No, my spectator don't reach yet. When my spectator come, I'm going to load him up. I don't want a spectator in the class. I want him to talk to me. I have created an environment that all of you should feel comfortable to speak, talk to me. Let us get this thing out of the way. I don't want nobody to, when I say test, oh sir, I don't understand this. You're on your own at that point, because I'm saying to you, let me know the difficulties or the challenges that you're now facing so that we can sort it out or sort them out, it or them, one or more. All right, let's go. So now, okay, so
sir, before you move on, sir,
yes,
the new guy, we have a WhatsApp group, so if you want to be added, you can send your number to the chat.
Very nice. That's very nice, Yannick. Very nice.
Sorry, you don't read not my message in the chat yet either.
Oh, you may read a message, man. It's about the alligator mode open to the term.
Him did read it.
Me did read it, man.
Okay.
Read it, man. And said yes. So Nigel, I'm going to say thank you.
Multitasking is not my thing, sir. I was actually typing my phone number. You know, hitting space bar in a document, it don't release the mic.
All right, good. All right, never mind.
Also, Nigel, sir, has a YouTube channel that can help you get up to date with Unit 1.
Yeah, we'll forward it to him when he joins the chat, the WhatsApp.
Nice.
Good evening again.
Thanks,
on my classes, you know. So you feel welcome already, Nigel? Yeah, man. Very nice students. Very nice students. Thank you, Andrew. Respect. ESPEK. All right, so let's go. So Nigel, I can't multitask. So hurry up and just put in the chat. I'm waiting for it. All right, good. Let's go now, Nigel. All eyes on deck. And I'm going to go through what it is that we did before. My piecewise functions. All right, so here goes. So the question says, determine if f of x is continuous at x equals -2 and x equals positive 2, given that f of x is defined as a piecewise function containing 3 separate functions. One is 2x minus 1, where x is less than negative 2, or x minus 3, such that x is greater than negative 2, but less than or equals to positive 2. And the third and final piece of the function is x minus 1, where x is going to be greater than or equals to 2. So it's called a piecewise function because you're actually doing the function in pieces. All right. Now, you want to see if when it is that you would have done all of this, you would get your graph as being continuous. Sorry, I sound distracted because I am wondering if at this point in time I should introduce it to a software to do the piecewise function, and I don't think it's maybe the best time to do it. Part of the reasons that I deleted the software from my phone, and I need to be reminded how to use it before I drop it to the class. Next thing will go laugh after me. Ryan will say that I'm old. But anyhow, let's go. So this is our piecewise function, all right? And I'm going to give you the software to, it's an open source software. So I'm going to give it to you so that you can see what it means by piecewise, all right? At some point in time, I'm also going to be, maybe today's a good day for me to do that. I'm going to also be sketching the graph of the piecewise function to show you exactly what is happening. So we are looking at the function. So it says at x equals negative 2. At x equals negative 2. One of the things I said to the class last week, as x equals negative 2, we first rule out the 1 year, because the 1 year is when x is greater than or equals to positive 2. We're not seeing a negative side of something here. So I rule out this. So when I rule it out, I can't make no mistake. So I know say, I see one negative 2 right here, so, and I see one negative 2 right here, so. So them 2 functions here, I'm going to deal with for the 1 here. But which one I do to the left and which one I do to the right is what I now need to decipher. All right. Now, sir says to the left is negative. Come on. All right, I'm trying to scroll. Sir says to the left is negative and is less than. To the right is positive. Then, sir, how you know that? Think about it. Think of a number line. Just think of any number line. Catch one piece of the number line. It don't have to be 0. Catch any piece at all you want to catch on the number line. And think of you going to the left of the number line. Don't it's going to be smaller than the number that you first caught on the number line? True or false?
True.
Yeah, man. And if you catch a number, any number on the number line, and you move to the right of that number, don't it then be greater than?
Yes, sir.
Yeah, man. So that's what we mean. So to the left is going to be less than. Sir, but it don't necessarily have to be negative. No. But it is that you would have subtracted something from it. Because if I'm at 0, to the left of 0, in fact, it's going to be negative. But if I'm at 4, to the left of 4 is still a positive number, but it's positive 3. But how I got positive 3 from 4, it means that I would have had to subtract something from it. So that's why I would call it negative, right? And incidentally, when I go to school, and also my teacher then used to teach it here, so that's why it's much harder when I go to school. This easy now, all right? So if you kind of think of the number line, anyway, catch on the number line. To the left of it is going to be a smaller number, we say negative. To the right of it is going to be a bigger number, it's positive, it grows. The left of it is going to shrink because you're losing something from it. All right? So now, it says, we're looking, so we know that it's these two. So the first one says, x is less than negative 2. Less than is negative. So what I'm going to say is the limit, I'm finding the limit, as x tends to negative 2 to the left. See it so? As x tends to negative 2 to the left. Sir, why? Because it says less than. So less than is to the left. Then, sir, them less than sign and greater than sign and greater than and equal to sign make a difference? It actually does. And it does, especially when it is that you're plotting your graph. And I will show you the plot of the graph, not the plot, the sketch of the graph a little later on. I just want to get the calculations out of the way, and then one day we just come in and say, oh, you know what, we're going to sketch graph. You don't need no graph paper. That's why I changed my talk from plot to sketch. You don't need no graph paper. We are only sketching. All right. So now,
sir, before you move on, where would we be doing the exam? What would we using to do the exam?
what do you mean? Platform or what? What are you
Yeah,
talking
platform
about?
and
Edicasoft.
Okay. Wow.
And you can ask me that question again, actually for maybe towards the middle of the semester when I'm giving you a mid-semester exam. So I'm going to mock the mid-semester exam as if it were a final paper, so at least you know exactly what is expected of you. As I said to you before, I apologize for how your other lecturers may have used Edicasoft. I know there are at least 2 students in the class who I would have interacted with before, who would have seen how I use Edicasoft. How I use Edicasoft is far different. Matter of fact, I'm supposed to be projecting something to Edico because I did something for you guys yesterday on it. But as I said before, I have some housekeeping matters to deal with. Please remind me, don't let me end class tonight without doing a housekeeping. Class ends at 7. Stop me at about 20 so we can deal with the housekeeping matters, please. All right. So because I'm going to the left, it says less than. I'm going to write x tends to -2 to the left, and then it's only one equation in my piecewise function that deals to the left, and is this 2x minus 1. So I'm going to write the 2x minus 1. Now that I write the 2x minus 1, we would have gone through the intuitive approach to know that when we say x is tending to -2, it means that x is not -2. X is only approaching -2. But when we do the calculations approach, we know say we can just assume that x equals -2. So what we are going to be doing, instead of doing the intuitive approach, remember, you know, the intuitive approach is long, and we don't have time for that long intuitive approach for the exam. If they ask you for it, you have to produce it. But in a question like this, you can go ahead and do the calculations approach. I expect you to use the calculations method. So what is happening, what is expected of you now, is to make a substitution. Anywhere in the function, which is 2x minus 1, you see x, you're going to substitute the -2. So this becomes 2 times -2, see here, so it's -4. -4 minus 1 is -5. So you've evaluated this first piece and you got -5. Let us see now if the function is well behaved. And we are going to be looking to the, as x tends to -2 to the right. Remember now, in order for us to truly find out whether or not a limit of a function exists, we have to investigate what is happening to the left of the function, as well as what is happening to the right of the function. What is happening to the left of the function and what is happening to the right of the function. All right. So to the right of this function, let us check. X is greater than -2. I'm not interested in x is less than or equals to 2 because 2 is not what I'm working with just now. I am working with -2. So I am ignoring this piece and reading from my x, from my variable. So x is greater than -2. So greater than means it's to the right. So that's why I have x tends to -2 to the right. That plus sign, as I told you down here, that plus sign down, come on. That plus sign down here means to the right. This means to the right. So I'm going to the right, so it's going to be x minus 3. And again, anywhere in the function I see x, I'm going to put -2, so it becomes -2 minus 3 is equal to -5. Now, one of the things I can say to you is that since the limit is tending to the same number from the left and the right, then the limit exists. We say that the limit is of a good behavior, it exists, and it's good to go. So the limit, so it is continuous, therefore, at x equals, it is continuous at x equals -2. Sorry, my phone just went off, and before Ryan starts, my phone went off. I was looking at Mason's response. I forgive you. I forgive you. All right, a team member is calling me. Hold on. Yes, Mr. Rowe. Mr. Rowe? How you do? It's not yet added? No, guess what? I apologize. Yeah, you're right. Right. Oh, yes. And the SCM3 was added sometime later. So I will add it for you. I'm in a class now, but when I get a little break, I'll add it for you. Uh-huh. Uh-huh. For what? For the foundation concept 3? Yeah, man, go on with the class, sir. Go on with the class for today. Go on with the class for today. Let us see what will happen. Because maybe what we have to do is maybe to merge from Mrs. Hall Francis. I think she has 4 students. So we may have to send over those students to you. But go on. No matter turn them back. Go on. Go on, what you need to do. But we may just have to do a merger of the 2 classes. Yeah, man. Bless you. Yeah, cool. All right, I apologize for that.
I'm jealous when I tell them that from 5 to 7 is our time.
Can I tell you about yes or no? I was, well, you know that I am team lead. So he's actually in a class now and not seeing the students turning up. So he was wondering what it is that he was supposed to do. So I just instructed him to go ahead and continue teaching. So this is what I was about to say, that, you know, every now and again, I may have a team member calling me, you know, just to, something may happen and just to give me an update. So I do indulge your forgiveness even before it happens. All right, so let's go. Right, so because these two numbers are the same, we will say that the limit exists and it is continuous. So I can make a conclusion right here to say that the function f of x is continuous at x equals -2. Now we need to check to see if the continuity works for x equals 2, or is it discontinuous? So it's either the function is continuous or discontinuous. If the function is continuous, then both numbers appear to be the same. If this number is -5 and this one is +5, they are 2 separate numbers. -5 and +5, not the same, 2 separate numbers. Then we say that the function is discontinuous. So let us check. These are my notes. I'm going to skip over the notes and I'm going to check. Why is it not scrolling? All right. So here my conclusion. My conclusion is, since, you know what? I don't like this conclusion right here, so I can cut it and I can put it closer to the one here, right? So this is my conclusion. So since the limit, as it tends to the left and the limit to the right are equal, then f of x is continuous at x equals 2. Then I give my notation, you know, to be honest with you.
-2, sir, not 2.
Yeah, I just said that to see if you're paying attention. Very good. -2. Forgive me, Lord. But you know, I just said something that I shouldn't have. Let's go. Yes. So let me just put the notes at the end and then just get the calculations out of the way. Yeah, I think that is better. So I'm making some notations after we would have done the stuff. Yeah, so it is -2. So now we're going to be looking at x equals +2. So now we're looking at the functions. We now look on the one there none tall, because the one has a -2. We see a +2 here, we see a +3. So it means that these are the 2 functions that we need to look at. 2 functions we need to look at. Okay, watch me now. So I need to look at the left and the right of the function. Which one deals with the left? Let us check. X is less than or equals to 2. Less than is to the left. Less than, L for L, less for left. Left for less. L and L. So to the left, so I'm going to have x tends to 2 minus, raised to the minus is going to be x -3. See here? X tends to 2 to the minus, means to the left is x -3. And again, we are using the calculations approach. So what we're going to do, we are going to assume that x is equal to 2. So we're going to say 2. Anywhere in the function I see x, I'm going to substitute 2. So this number becomes 2 minus 3 is equal to -1. 2 minus 3 is equal to -1. So write it down. And then what is going to happen now is that we need to look at the function to the right. And of course, this other one here has to be to the right. And let us check. X is greater than or equals to, yes, sir. This one is to the right. And the function that deals to the right is going to be x minus 1. So see, we have the x minus 1 here. And similarly, anywhere in the function I see x, I'm going to substitute 2. So it's going to be 2 minus 1. And 2 minus 1 is equal to positive 1. Hear my story. Since the limit to the left is not equal to the limit to the right, then f of x is discontinuous at x equals 2. They're not equal. It is misbehaving. It's not equal. So therefore the function is discontinuous. So when we plot in the graph, it means that this graph will connect to this graph because it's continuous. But when it reaches somewhere around here, so there's going to be a break in the graph. There's going to be a break in the graph, right? And I don't want to overload you. I want you to be able to just appreciate the calculations, and then we sketch the graphs. So I can just put you on guard. I'll do some sketching with you on Thursday, all being well. Yeah. Okay. Are there any questions regarding that before I move into our examples or homework? Oh Lord Jesus, I don't think I did the homework, did I? Are there any questions? Okay, good. Yes, please. I hear.
Not yet, sir. Not yet.
No, man, I heard a faint, sir. A very faint one.
No, it's me. I said no, sir. No question.
Okay. Good job. Because in now, Sasha, I was about to say that I'm hearing music in my head, and that would not be a good thing. All right, let's go.
Yes, clean.
All right, let's go. So example 1. Rockstone, what me out of the surface is sketch graph. I never gave you this one with sketch graph on it. No, don't worry about it. Even if I gave it to you, don't look at it just yet.
I didn't work it out, sir.
All right, yeah. Okay, yeah, but don't look at the part where it says sketch graph. Even if I'd given it to you, I didn't see that it is there, but even if I'd given it to you, don't worry about it yet. In another class, I'll do the sketching of the graphs with you. I notice I'm not saying plot because you'll never be given a graph like this to plot. It's more sketch that you'll be doing. All right, so it says here, determine if G is continuous at x equals -4 and x equals 1. Oh, but hold on, sir. Me the thing say it have to be like -2 and +2 and -3 and +3. Me never know, sir. It can mix up. Absolutely. It can mix up. Just like other one you mix up. X is equals to -4 and x is equals to 1. And they define for you what G of x is. G of x don't look too cute neither, no. A half x plus 3. This G of x looks like Ryan. And then we have a 2x plus 9. And then a 11. That one look like Charlie. Very nice. All right. So but don't worry about how they look. I don't want any of you to go into the thing and say, Jesus, sir, this looks ugly because I have a fraction. No, fret not. One of the things that I will say to you, students, is don't look at the function and say to yourself that I can't work this function, or I don't know what this function is saying. That's not your concern. Your concern is to manipulate what the function is, right? So I will give you certain tasks, and when I give you those tasks, you are going to know what to do. So the first thing that you need to do right here is to investigate what happens at x equals -4. You're not even looking at the function yet. You know them asking if the function is continuous at x equals -4. And that's the first one you want to do. Then survey after start with -4, could start with x equals 1, whichever you choose. Whichever you choose to start with first, not a problem for me. So if I look at x equals -4 first, what it is that I'm going to be looking at is I need to investigate the limit as x tends to -4 to the left, see so I can write this down. The limit as x tends to -4 to the left, I'm also need to investigate the limit as x tends to -4 to the right. Now I'm going to write down them two something here first, because I know that I'm looking at x equals -4. So the mere fact that I'm looking at x equals -4 suggests to me that I must investigate the limit as x tends to -4 to the left and x tends to -4 to the right. X tends to -4 to the left and x tends to -4 to the right. All right, so that's what I must look at first. And once it is that I look at those, then I can find out now what it is that I'm going to be needing. What it is that I'm going to be needing. Okay, sir. x tends to -4 to the left, I need to look now at my function to see which one is tending to the left. Which one of these tending to the left? Now remember, I am not interested in this one. Sir, why? Because I want to say 1. We're not interested in a 1, we're interested in a -4. Oh, that means, sir, we're not going to look on the one either. No, I got you, sir. So that means, sir, this is to the left because it says x is less than. And once it's less than, it's to the left. Very good. So to the left of it is going to be a half x plus 3. Anywhere in the function, a half x plus 3, you see x. I'm going to do the first question. This thing is annoying me. So let me just fix it because. All right. So when I look at the function here, I see that this is, I didn't want anybody to get confused and call this -2. So that's why I put it in parentheses. So when I look at this here, anywhere in the function, I see x, I'm going to put in -4. This is now a half times -4, see so? A half times -4 plus 3. Now a half times -4 is going to be -4 over 2, which is -2. -2 plus 3 is +1. Put it in a calculator. Put it in a calculator. It's going to be a half times -4. A half times -4 is going to be -4 over 2, and -4 over 2 is -2. -2 plus 3 is +1. Okay, moving. And then we need to find the other function, but look at the other function. We're not looking at this x under 1. The other function is x is greater than -4. X is greater than -4. So it means my function to the right is going to be 2x plus 9. See here, 2x plus 9. And again, anywhere in the function I see x, I'm going to substitute -4. So it becomes 2 times -4 is -8. And -8 plus 1, plus 9 is equal to +1. Oh, sir. The two of them are +1, sir. That means it's continuous. Let us check. Since the limit to the left is equals to the limit to the right, then f is continuous at x equals 4. Yes, you are correct. X is continuous at x equals -4. I'm going to stop right there and ask, did anybody get that right? That first piece there, right?
Sir, that did you on it already.
Sir, only Charlene.
Yes, sir, I got it right.
It did do already, Charlene.
This question did do already, sir. So I already did 3 and 4.
3 and 4. All right, no problem, no problem, no problem. Okay.
So, sir, one question. Both answers have to be the same for it to be continuous?
Can you repeat your question, please?
If both answers has to be the same, like the answer is 1 for both of them for it to be continuous.
Very good. Say it one more time. But don't ask it as a question or make it as a statement. No, I'm serious. I'm serious.
Both answers has to be the same for it to be continuous.
Very good.
Okay.
Very good. All right. So yes. So my answers must be the same in order for it to be continuous. So if it is not the same, please don't write say continuous, right? Then 1 mark or 2 marks separate an A plus from an A. All right, so And it also separates a D plus from a C minus 2. So, but we're not talking about that because none of us will be in that dilemma at all. All right, very good. So you notice I kind of jukey jam a while ago, and you're wondering why. You must be saying to yourself that sir is distracted at some point in time, but I just did a whole lot of stuff and I'm just waiting for it to just percolate somewhere into your brains. And I got one question so far, and I'm really hoping that the others would have seen it. All right, so I made a blunder by saying that this was a homework, so it wasn't, but no problem. It's a good opportunity for Mr. Nigel to catch up on what it is that he would have missed. All right, let us go and let us look now at x equals positive 1. So we're now investigating what happens when x equals positive 1. So why is this thing not scrolling? Come on, man. So let us look at it when x equals positive 1. So again, I am not interested right here. So you know why? Because this is negative 4. I'm only interested now in positive 1. So the piece here too, with the negative 4, I'm not interested in. So I can block out this out of my head and just think that this is going to be x is less than negative 1. Sir, you said less than. L for less and L for left. That means this is going to be x tends to 1 raised to the minus sign because it's to the left. Let us check to see if you are correct. And yes, you are. And it's going to be corresponding with the function 2x plus 9. Very good. 2x plus 9. Very good. So what is now happening here? What is now happening here is that having identified the function that corresponds to this limit, anywhere in the function I see x, I'm substituting 1. And you have to be careful. You see, because we did a question before and was talking about 2, I just went back to 2 a while ago. So you have to be careful. Whatsoever you put in, that's what you're going to get out. All right? So if your input is incorrect, that means your output has to be incorrect. All right? Let's go. So this is going to be 2 times 1, which is here, plus 9, and I get 11. Sit back, relax, and enjoy the flight, because I'm about to touch something that is new. 11 is greater than or equals to, sir, it is greater than, so it means that it is to the right. Very good. So anywhere in this function I see x, I'm going to substitute 1. Is there any x in this function?
No, sir.
Oh, sir.
All right. So my answer is going to be 11. And there's a nice little story about that one here. The limit of a constant is the constant itself. Let me see. I don't know how many did write that story. You know. What a man. Stay back so.
Sir, you never read that story there.
Never read the story.
Sir, you did say it one long time, you know, you did say it one long time.
Say, geez,
They never write it, but they did say it. Remember my very first class.
Nice, nice. So, you know, I'm going to write the story, you know, because, you know, we love to tell stories. Jesus, how do I do this? Recall, R-E-C-A-L-L, recall the limit of a constant, O-N-S-T-A-N-T, is the constant itself. Very, oopsie daisy, constant itself. It's very important.
L-I-N 2x plus 9.
All right, so recall, the limit of a constant is the constant itself. Very, very, very important. You cannot forget that. You can't forget it. You can't forget it. The limit of a constant is a constant itself. The limit of a constant is a constant itself. Sir, what is the limit as x tends to a million of 1? 1. The limit of a constant is a constant itself. The limit of a constant is a constant itself. All right. So now, when we look at this one here, we recognize that both of them are tending to 11. So we make our statement. Sir, do we have to make a statement? Yeah. The question asks you if the function continues at x equals -4 and x equals 1. So your statement is now answering the question. And it so happens that this function is a continuous function both ways, right? As opposed to the one that we got before. All right. Now, let me just jump to something here. Let me jump to something here. And, and say to you that in this particular case, we looked at, why is school not working? We looked at an example. No, I gave you an example in class here with 3 functions constituting my piecewise function. And then we did a first example with these 3 functions. And then I gave you one now where we have only 2. Where we have only 2. So I can go with 2, we can go with 3, we can go with 4, as many pieces as they so desire. All right. So don't be alarmed if when you're going to the exam I say something with 4. But sir, you never did not with 4 before. Don't worry about it. I don't teach by example, I teach conceptually. So once you understand the concept, you just go through and do it. Put it this way. If you know how to cook chicken in Jamaica, when you go to America and you see the fowl them look much bigger, you can still cook it. A little thing happened to me a couple summers ago. I remember, you know, a few of us in the family went up and we wanted some food. And we bought the food, man, and the night, and the food came up to about $80-something. It was a carload of us. And it was my turn to buy. And I feel a lump on my throat when I have to count out $80 US to pay for food. And I say, this is the last time I'm paying food for $80. They said, "You better eat every bit, all the paper bag when we eat." You understand? So the following day, we got up and I said to my mom, come, we're going to drive over to the supermarket and we're going to buy our food and we're going to cook at home because guess what? The fast food business here is way too much money. So we went to the supermarket and she said, what do you feel like? I said, no, pick up some chicken foot, you know. And me, you know, the big people, them big public supermarkets have about chicken foot. I remember from the package, them call it chicken paws. They said, oh, you know, a chicken foot in name in Jamaica. But the truth is, when you look on them chicken paws, think of a baby hand. Oh, God, I shouldn't be saying that because I can't eat it anymore. For them chicken foot, no matter like our chicken foot, you know. For them chicken paws, they can't get meat off of it, so to speak. You understand? So the point I'm making is, irrespective of where you go, it is called something different from what we call it in Jamaica. You can't go far and ask them for hand cut. They're gonna say, what is it? Because when they cut up them chicken, them take off a piece and throw away. You understand? They don't, or it is sold to one of those inner city corner shops where the people living in the inner city go and can get it for $1 a pound or 50 cents a pound. But in the public supermarket and in the Winn-Dixies, you're not going to find the chicken back unless you buy the whole of chicken. All right? But the point I'm making is chicken in Jamaica is the same chicken in foreign. The size chicken may differ. The shape chicken may differ. So sometimes they may yell frog until it's a chicken, but irrespective of what it is, just think about it. It is still chicken. If sir gives you a piecewise function with 2 functions in it or 3 functions in class, but when you go into the exam or the mid-semester, you see 4 functions, don't be alarmed and say, sir never teach me that. That would not be true. Follow the concept. Follow the principle. Me couldn't say, but me can't cook chicken paws. Are the same chicken foot. It's the same chicken foot. but it's just that them call it differently. Hold on a second. I think I have been talking enough. Am I clear? Is there something that somebody would want me to 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 re-explain? It doesn't mean that you have to follow 100%, but at least you're understanding so far. If that makes any sense.
Can I get it so far?
Okay, nice. Somebody else is coming in.
I said same.
Okay, cool. Why so make it answer me so strong? John, no, sir, so you need help with pass with a question on minutes. Okay, no problem. Since YouTube link in the description. All right, good. I was just checking on the chat. All right. Sounds good. I'm happy. So let us run through. Was this a homework question now?
No,
3 and
sir.
4.
Oh, 3 and 4. All right, no problem. So let us run through this question. I will run
Sir,
through
one question, please.
Go ahead, please.
Sir, when we're doing it, under the limit to x, we should always have the x to the negative, the 1 and the negative over it, which mean left and right?
Yes, on the bunches.
Okay.
Some you don't know which one are the left one and which one are the right one. So yes, you are correct. Okay, moving on. My scroll is not working. Come on now. All right, let's go. So example 2. Example 2. Example 2 says. Example 2 says we need to determine if R is continuous at x equals 3. But sir, this one, the others it gave us have 2. But oh, this one only have 1. Anybody can figure out why?
Because both of them are 3. Oh wait, this is less than.
They just want you to check to see if it's continuous.
Yeah, but why the others? My question is, why the one here have x equal -4 and x equal 1, and the one up here they have -2 and 2, but the one you don't use to just have x equal 3. We don't understand that. Why does have x equal 3? Why never have x equal 3 and x equal something else?
Because I think it has 2 functions in there.
Very good. All right, very good. So I just asked her to see if you guys were looking carefully. So it's only 2 functions. So if you see, so I'm just showing you the patterns of it. So if you have 2 functions, if you have 2 functions in the piecewise function, you're going to have just 1 piece to look at. If you have 3 functions in the piecewise function, you're going to have 2. That means if you have 4, how much you're going to have right here? So
3.
Ah, yes, Krish, you're good. Nice. All right. That was just a little brain teaser just to see if you guys are really following, and I'm happy for that. Let's go. So R of x is going to be 2x minus 9 if R is less than 3, and x minus 3 if R is greater than or equals to 3. Sketch the graph. Nah, not yet. So we need to investigate. Hello, sir. I see now, sir. So when we have 2, it means that we're not going to have the combined piece in the middle, don't sir? Very good observation. I was here to talk about combined piece. All right, thanks for asking. I mean a piece here where you have this is greater than equals to this, but this is less than equals to that. How to have it when you have only two. When you have only two is either bam or bam. The one you have to go one middle piece now, but see if piece of this can cover this and piece of this can cover this. Eh? So we mix it up because remember, you know, this must relate to this and this must relate to this to find out whether or not it's continuous. But in other two piece one here now, one of them two are going to be related. All right. This your mother have them two pitney here, two children, and your father have these two children, and then no, this is your mother having a child here, and then there is a stepchild that come in. So this one said, "Me, you're not related." And say, "Well, me have the same last name, but we have two different mothers." I don't care. We say the same father, right? So there's something right here, so connected here, and there's a connection here. So guess what? We have a blended family right there. Blended family. So we're now going to talk about who is half brother. As a matter of fact, it's something that I totally dislike. Don't tell me say I'm your half brother or you are my half sister or whatever the situation is. We are brother and we are sister. So this is the half business here. So is one something on a piecewise, one function g of x. All right, let's go. And then now, when you look at this, you're going to see, okay, not a problem. X equals 3. Now, once it is that you talk about x equals 3, there are two things that we need to do. We need to look to the left of 3 and the right of 3. So we're going to find the limit as x tends, and this is what I'm going to write down. The limit as x tends to -3, rubbish. The limit as x tends to 3 to the left. And we're also going to look at the limit as x tends to 3 to the right. All right. Now, so when x tends to 3 to the left, this is x is less than 3. That means this is the function we're talking about. 2x minus 9. That's the function we're talking about. 2x minus 9. X minus 9. All right. And then anywhere in the function I see x, I'm going to substitute 2. So it's going to become 3. I'm sorry, not 2, but 3. So it becomes 2 times 3 minus 9, and 2 times 3 is 6. 6 minus 9 is -3. All right. Similarly, I'm going to be investigating what is happening at x minus 3. At x minus 3. X minus 3. And when I look at x minus 3, anywhere in the function I see x, I'm going to substitute 3. So it becomes 3 minus 3, which is equal to 0. Something not right. Something is not right. Copy. And then I just have discontinuous. I don't like, you know, that's just dry. So I'm going to do that and say, since the limit as copy paste. Let me just find a not equal to sign, please. Then it's not f of x. This one is r of x. At x equals 3. All right, so let me know. Let me hear now. Who got this one correct? Oh, sorry, it says it's number 3. Forgive me. Keep forgetting. All right. So that's our solution. Are there any questions to this one?
No, sir.
All right, good job. All right, so remember, guys, you're not allowed to sit in my class and not understand, but fail to say something in class. Opheline, go ahead.
No, sir, I wasn't saying anything, just
Oh, okay.
ruminating.
Okay, no problem. All right, so here goes. Oh my Jesus. You know what happened now, guys? I absolutely did not do questions 3 and 4. So
Just scroll up back a little. I was checking the end part of what they just did a while ago. The statement that you make. Okay. All right, cool. Finish.
all right, so you have to work with me now. So we are going to do número 3. Now it has 3 terms. What I'm going to do is I'm just going to copy that one and just work my solution into it. All right, let's go. It says, if f of x is continuous at x equals -2, x equals -2, and x equals +2, given that f of x is equal to that piecewise function. Then there's one for find out if it's continuous and one. Okay, all right, no problem. So we're going to investigate what happens at -2. So what happens at -2 is that I am going to look at and I'm going to just do it how I want you to do it. Now look at the first thing that Sir did. The first thing that Sir did is to write the limit as x tends to -2 to the left and the limit as x tends to -2 to the right. I don't even look at this. You notice I don't even read this. I am not even interested in this just yet. What I'm interested in is to know set. I'm asked to find the limit to find out whether or not it's continuous at x equals -2. So I know I have to find these 2 limits to see whether or not it is. All right, so I look into the left, looking to the right. Now I'm going to say, I'm going to be looking at the function, the piecewise function that is, to see which of the functions deal with to the left. And I'm looking of -2. I'm looking here, and I strike a line through this because this one's clearly a +2, not interested. The piece is a +2, not interested. So this piece of here says x is less than -2, but less for left. So less than is to the left. Oh, so the one to the left is going to be 3x plus 7. So this one here is going to be all of 3x plus 7. And similarly, to the right, x is greater than -2. Now, once it is greater than it means it's to the right. So the function is going to be x squared minus 5. Then, sir, you can have all x squared into something to never see do a question with that. Don't worry about what I do. What I do is questions that I make up out of my head. The people there may be very mischievous and give something that is totally different from what it is that I would have done. Sir, then over go do the question. Don't worry about it. It's a concept. So if you understand how it is that we do the stuff, any function the man them give you, you're supposed to can work it. All right? It's a promise. Trust me on that. So the function is going to be x squared minus 5. So again, anywhere in the function I see 3x plus rubbishness. Anywhere in the function I see x, I'm going to substitute -2. Anywhere in the function I see x, I'm going to substitute -2. So that becomes 3 times -2 plus 7. And 3 times -2 is -6. And -6 plus 7 is going to be +1. So I get my +1 right here. Similarly, Anywhere in this function I see x, I'm substituting -2 again. So it's going to become -2 squares. Now, when I raise a negative number to an even power, it becomes positive. So -2 squares is going to become +4. And 4 plus 9 is 4 minus 5 is
5, sir.
equal to -1, don't?
Yes, sir.
So is that continuous?
No, sir.
No.
Oh,
So,
sir.
right. So I can write right here. So DIS continuous at x equals -2. And I'm going to change this to say the limit as x tends to -2 of, what is we know, 3x plus 7 is not equal to, so we find that not equal to sign, not equals to the limit as x tends to 2 to the right of x squared minus 5. Look at that and tell me if you agree.
Agree.
Very nice. Is there anybody in the class that did this first piece with x minus 2 and got a different answer than what we have on the screen here? If so, just be honest with yourself. Speak to me so at least I can know what it is that I need to work on to get you to where I want you to be at.
Me, sir.
What?
The first limit, sir, for the 3 times the -2, sir, I get -6.
Me too.
Plus 7.
I will get add -67 to plus 7.
Oh, sir, me see it, my bad.
Davia, take out your lunch money for the rest of the week and hand it to me through the microphone.
Sir.
Will do, sir.
Yeah. Yes, Krishna.
What about I got those 2 right, but what about the third one?
Which third one? We not reach say yes, Krishna. We'll go to it now. We not reach say yes, Papa. We'll go to it now.
Sorry. My bad.
Yeah, man, that's fine. That's fine. That is perfectly fine, son. Perfectly fine. All right, so let's go. Now you notice I took a pause a while ago. It's not that I don't know how to do the rest of the question, you know. It's that I'm just giving you enough time to look back at in your books strategically what you would have placed there versus what it is that I would have done on screen. Matter of fact, take an extra minute. I'm gonna hydrate myself. 1 minute, please. Okay, my students, I am ready for you now.
Hold on, sir. I
Yes,
noticed one small difference between yours and mine. Limit -2 and limit -2 positive. Yeah. That has to be there?
Yeah, man. Because what it is that I'm saying to you see this 3x plus 7 now. This is the limit to the left of -2, and this is the limit to the right of -2. So I have to tell you the position. You can't just have them arbitrary.
Oh.
So this one, right? So it's, let me see now. How do I say it?
So I wouldn't lose marks even though I get the answer?
I'm not going to say not going to lose any mark, because if I see I'm going to take off a mark or two, it's going to be very important. Put it this way. Put it this way. Thank you, Lord. Put it this way. So you have siblings. You have siblings, and them one in America and the other one in London, and they gave you £100 and $100, and the one that gave you the £100 says, "This is for your little brother," and the other one say, "Such and such give your brother already, art never give your sister." So one gets £100, one gets $100. You can go and give the other and mix it up and give them the different money.
Oh, I'm serious now.
Because you see, one may say, "But sir, duh, it's $100. Two of them are 100. Yeah, you agree with that. But when they convert, one is going to be more than the other based on the Jamaican exchange rate. That everybody knows that the pound sterling, weighs a little heavier than the US. You see the point I'm making?
Yes, sir, I get to know.
Yeah, so it is important for you to differentiate which is which. All right, let's go. So we're looking now at x equals Rockstone. At x equals 2. I saw this one a while ago and got confused. X equals 2. Let me change that. X equals 2. All right. So in our investigation, we are going to be saying x equals 2. Oh, sir. Right about off the bat, I'm taking out this piece here because I'm not interested in this. Not interested, not one iota at all of that, right? And I agree with you. So what we are interested in is x equals +2. So if you look at it now, this piece here we're not interested in, so we can block it out. What we're interested in now is going to be x is less than or equals to 2. The moment we say less than, it means it's to the left. L for less, L for left. Less than is to the left. So the limit as x tends to 2 to the left. So look at what I'm going to write. The limit as x tends to +2 to the left, and the limit as x tends to +2 to the right. And the function to the left is going to be x squared minus 5. The function is going to be x squared minus 5. And anywhere in the function I see x, I am going to put 2. Anywhere in the function I see x, I'm going to put 2. And let me just show you what it is that I'm talking about. Anywhere in this function I see x, I'm going to put 2. So this becomes 2 squares minus 5. See here? 2 squares minus 5. 2 squares is 4. And 4 minus 5 is -1, don't it? Somebody say yeah.
Yes, sir.
Good job. And then now, the other one says x is greater than or equals to 2. That means this one is to the right of 5x minus 11. The function is 5x minus 11. Anywhere in the function I see x, I'm going to substitute 2. Anywhere in the function I see x, I'm going to substitute 2. So 5 times 2 is going to be 10, and 10 minus 11 is going to be -1. So both of them tends to -1. Do you agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
So,
Yes, sir.
So therefore, the function is continuous at x equals 2. Agreed?
Yes, sir.
Agreed.
Agreed.
Yes, sir.
Good job. All right. It's now your turn to ask me the question. Is there anybody in the class that don't see it? And guess what? What I don't want anybody to be suffering from is everybody I say yes, yes, yes. Me now answer serious because I'm going to think there's something wrong with me. You don't care with them. Don't look at those who say yes and look at yourself. If you're not seeing it, say, sir, me never get it. Is this f of x? And let me know so that I can be in a position to help you. All right? So that is it. So it is discontinuous at x equals -2, but the function is continuous at x equals +2. Any questions? Speak now, or forever you will hold thy peace. And the vow says, till death do us part. So they can't turn back from calculus 1 right about now, as a matter of fact. Only into it already. Till death do you part. Calculus 1 is here to stay. All right, let's go. All right, I'm going to see if I can run through that one a little quicker. Number 4. Let me ask the question before. Oh, hold on. Oh, number 3 was double. Number 4 is single. Is it continuous or is this continuous?
Continuous, sir.
It's continuous. All right, let me just be lazy and just copy from here instead of so that I can move much faster. This is really the end of the class. You see, my unit 2 is continuity, and I don't want to go to continuity tonight. Oh, forgive me, I was making some stuff here, so some of these functions are the same because I was just copying and pasting and copying and pasting. So I need to do some more. Lord, I have homework to do. Tell me, Lord. Hold on now. So all the items jump in this and don't even write the word solution. All right, let's go. First things first, solution. Let's go. So I have my solution for that. And then this one here. Oh, I have my solution for that. Go to that. No, that's not what I want. Go to end. Then I'm gonna paste this table right there. All right, so let's do this one quickly, and then you notice me put a little troublesome on it. If I could be your homework, look at troublesome on here, and you know, it's all right. I'm gonna get free to them and set some questions for you. All right, some other questions that is. All right, so example 4. Determine if f of x is continuous at x equals 1. So we know that is x equals 1, so I need to look to the left and the right of x equals 1. So the first thing I'm going to do is x equals 1 to the left, x equals 1 to the left, and then x equals 1 to the right. X equals 1 to the right. Okay, now x is less than 1, that is to the left. So that means this is going to become 6 minus x, 6 minus x. And anywhere in the function I see x, I'm going to put 1. So that's 6 minus 1. What is 6 minus 1? Anybody? Somebody?
5, sir.
5? All right, I got the same 5. And of course, the other one is going to be to the right. So it's going to be 2x plus 3. And anywhere in the function I see x, I'm going to put 1. So that's going to be 2 times 1 plus 3. And 2 times 1 is 2. Very good. It is indeed continuous because 2 plus 3 is equal to 5. Very nice. So that one is easy. Very nice. So I can say that the function is not discontinuous, but continuous at x equals, what is that? X equals 1. And then no, this is a limit as x tends to, come on, don't do this to me now. As x tends to 1 of 6 minus x, and that is going to be, oh no, undo. That's going to be equals to, and that is equals to 1 of 2x plus 3. All right, so you can just double check. Oh, and that's not r of x, it's going to be f of x. So when you look at that now, you're going to get both to be 5, so that means the function is indeed continuous at x equals 5. No, at x equals 1. So my answer is 5, and the function is continuous at x equals 1. Now, I am stopping here for now. I'm stopping here for now. I need to do a little housekeeping with you. And by the way, yeah, no, when I get into the housekeeping, I deal with that. And but importantly though, I need to take your questions. Is there anyone in the class that has a burning issue or something that I would have done or said that you're not understanding, and try as I may, the explanation just now cut it for you? Such a man. Talk to me. Let me hear what is going through your headspace. And in the same breath, guys, I'd like to know, this is now is this a third week? This is a third week, don't? 1, 2, 3.
Yes, sir.
Yes, sir.
Yeah, this is after the third week now, the start of the third week. I need to know how it is that it's going. I need to know, while you tell me what it is that you're understanding or not understanding, I need to hear from a few of you if how it is that I'm conducting the classes. This is for me personally, so that I can improve on my delivery, so that I can meet more of you. I've been hearing other colleagues of mine speaking about students, some students not being able to connect in the class, and the students saying them can't learn online and so forth and so on. To be honest with you, I feel that I'm reaching my students online, but I don't want a feeling. I want to hear from my students. Am I reaching you?
Sir.
Talk to me. Yes, please, go ahead.
There is a question in the chat.
Okay, sorry. Let me just check that. Why would you say it's continuous or discontinuous? No, it must unmute and talk to me. Mr. Anderson, sir, I want you to unmute and have a conversation. You don't talk to me in class, Mr. Sean. AKC boy. That's how you guys on the other side of North Street behave with you. Come, talk to teacher. Unmute and talk to me, Sean. All right, so while he finds the unmute button, I need to hear from you guys. I need to hear from you guys. Talk to me.
This class was good.
All right, good. Am I able to reach you, Krishna, in an online medium?
Yes, sir.
All right, good. All right. Yes, Sean. Finally, you found your remote to unmute. Go ahead, Papa.
Basically asking how or why would you say when you limit the function?
Sean, you just said that in join up a while ago.
Sorry, I'm trying. Why would you say how would you decide that it's either continuous or discontinuous?
Okay, very good question. All right, thank you. Krishna, unmute for me, please.
Yes, sir.
You said something earlier. Can you repeat it?
Both of the answers have to be the same.
For it to be
continuous.
And what happens if it is not, if they're not the same?
Discontinuous.
Very good. All right. I know you weren't here, Sean, because I was looking for you and I didn't see you. I know you joined late, but you and I will have a conversation. Yes. So when you check the limit to the left and to the right, and if the answers come out to be the same thing from the left-hand side and the right-hand side, then you can say that the function is continuous at that point. If on the other hand, when you evaluate the function at a particular point, look at the point you're talking about. I'm evaluating f of x at the point x equals 1. At the point x equals 1. All right, I'm evaluating the function at the point x equals 1. Now, when I evaluate the function at the point x equals 1, I must look to the left of x equals 1, and I must look to the right of x equals 1. So see here, I'm looking to the left of x equals 1, and I'm looking to the right of x equals 1. Now, to the left of it, I arrive at a number 5. And to the right of it, miraculously, I arrive at the same number 5. So because I arrive at the same number, I'll be able to say that since the left-hand side of the limit is equal to the right-hand side of the limit, then the limit is continuous at the point x equals 1. Watch this one up here now. At x equals -2 for that function, all right? At x equals -2 for that function, what happened was I got to the left of the function. All right. Krishna, I think this was you again. Remember, you were asking me the difference between yours and mine is that you didn't have this, I didn't have this. Know that I can read a function without looking at what was given to me as a piecewise up here. I can just read right here and say this was to the left and this was to the right. So what I could do, Krishna, is I can literally write back the question, the original piecewise question, just by looking at this piece here and the other piece down here. All right. So I can read this and say to the left of the function, to the left of -2, the function is 1, and to the right of -2, the function is -1. Now, the mere fact that these two functions differ suggests to me that the function is discontinuous. I think you'll have a better, well, not better, but I think you'll appreciate it more when I sketch the graph for you to see what I mean by continuous and what I mean by discontinuous. And that's fine. That's perfectly fine. If you don't have to understand that piece now, because I don't do it yet, so you don't have to understand it, right? Just what I want you to, sorry, let me just clarify that. What you don't have to understand is what it is that, how does continuous look and how does discontinuous look? No worry about that piece yet. I don't show you yet, no worry about it. What I want you to worry about at this time, not just Sean, but for the whole class is, once the two answer them, the left and the right come out to be the same something, be concerned that you're going to say that it is continuous. That me want you to catch. And if when you look to the left and right of the other function at a particular point, you recognize that the answers are not equal, be ye worried that you must say that the function is discontinuous. Then, sir, what it means by discontinuous is that the two of them don't give the same answer, but sir, me can't picture it. Don't worry about that part yet. Picture this. You'll see it next week. You'll see it next week. I mean, if I wanted, I could have done it tonight, but I don't want to give the overload. I'm recognizing that the class is growing. I think I have 19. I may have about 21 of you now in the class. It is growing, and I really want you guys to catch what it is that we are doing. Okay, does that answer your question, Sean? Is it clearer to you now, Pops?
Yes, sir.
All right, good job. All right. Are there any other questions? Any other comments? All right, Nigel, I'm going to ask you, baptism by fire. How was the class, Papa?
First session was informative.
What do you say?
Didn't get that?
No, I didn't get it at all. I don't think anybody got it.
The first session was very informative.
Oh, informative. Okay, all right, good. All right. Jermaine, unmute and talk to teacher. What is it? Newbie. Speaking, gone speaking, you know that? It's all right. Shall leave it to you with the keys. Karika.
Yes, sir.
Yes, Nigel.
Nigel here. Is it possible we can talk after class?
Yeah, man. Looking at in the what do you call it? The WhatsApp group. You'll see Muscular Shan. That's me. You can just call me 330-7311.
Yes, sir.
Yeah, man. Cool. Karika. I don't like when it's a silent in my class. Talk to teacher tonight, Karika. How is it? Wait. Everybody let them go on a sabbatical. I hope you guys are not just logging into my class and not talking.
We are here very in tune and
okay.
Well,
So
I'm here.
Yeah, talk to me, Ottilie. Am I reaching you? That's what I'm wanting to know. Am I reaching you? Are you understanding? Are you learning in this online medium?
Yes, sir. I'm learning in the online medium in that it's in some cases, yes. And I say in some cases, it's better for me. As me can, actually do other things, but still being
focusing.
still focused. And then versus when I was at class, with my other colleagues, sometimes I get distracted. Sometimes I talk to them and I miss something or whatever. But I can't use my phone and take screenshot and I can. So me kind of it's okay for me.
It's okay. Fair enough. Okay, Andrew, you're the last one. Go ahead, Papa. Andrew?
Yes, evening everyone. So far your delivery is really good and your explanation on how you go through your examples, right? So it is going on fine. What I might have missed or might not understand, I know that you have given the material so that we can go back through the explanation both in this PDF form that you usually send in the group and also your YouTube channel, because I went through it over on the weekend. You loaded it on Saturday.
Right.
Because I was going through the past papers, mainly through the limits, right, and some of the concepts that I had a little problems with the past paper. I just did a little review through your YouTube channel, right. Even though still I do have some questions on the past paper that kind of miss me a bit, though.
No problem. All right. So what I'm going to say to you, Andrew, is I can talk to you about 10-15 minutes after class, and then we can just clear up those, and then come tomorrow, Thursday, we can get through some past papers. What I wanted to have done tonight, as I said to you, that my aim is to do some past paper questions, at the end of each class. But I was watching the chat today, and I said to myself, let me just spend some time. So you notice how slowly I moved today, because I went over all the examples I did in class last week, because I know Nigel was here. Say thank you to Nigel. I wanted Nigel to catch this part of it, so at least what it is that he's going to review does not have to include this portion here. But also is to give you guys an understanding. And what I liked at the start of the class were the questions, sir, hold on, before you read us something there again, so it gave me an opportunity to even improve on the document that I would have sent. Now, Nigel, what I do at the end of the class, I will share my notes with you. I keep saying that it takes quite a bit of time to prepare, so I don't want anybody to make it gather dust. I want you guys to use it. Now, each time I send, I would recommend that you don't print the document yet. I know some people, will when they go to work, they'll print it and have the hard copy. Don't print it yet. Don't print these documents until I would have complete the unit, because once it is that I'm still in the unit and a question is asked, chances are I'll scroll up just to add something or to copy something or to just improve on the document, like I did tonight. I had only 2 points and I put in 3 more points. I put in these 2 points here, 2 and 3, and I put in point number 5. So don't print the document just yet. Wait until I say to you, okay, new unit, and then you can go ahead and print it, because I would have sent you the final copy of, so to speak, of what it is that we have here. All right, so I have 5 minutes and I want to talk to you about some housekeeping matters with you. Were you guys informed of a town hall meeting today or tomorrow?
A what, sir?
A town hall meeting.
No, sir.
No.
No. All right.
What time, sir?
I'm not sure. I'm not sure. I thought the information would have gone out. All right. So there are some new developments that I know you have a very effective head of school. I don't want to say just no to you then. What I will say to you is um, we will continue to have our class. You don't have to worry about what is going to happen. We'll still continue to have our class. But the examination, the only thing I will say to you at this point in time is that the examination will be pushed back from December to sometime in January. And the reason for that is to facilitate those students who have not yet started, because they recognize that the CXC results are still out. So there's going to be a delay or a pushback for the exam.
I think a lecturer told us that as well,
Okay.
sir.
Okay, great. All right, good.
January.
Right. So it's going to be in January. So yes, please go ahead. Nestor, go ahead. All right, Nestor, I'm struggling. I can't hear you.
Oh, sorry.
Go ahead.
You hear me now?
Yes, on.
The CXC result. What? Like, can't you just do our exam?
You're gone again, Nestor. You're gone again.
Have any effect?
Go stand up at the
Hear me
window,
now?
Nestor. Yeah, yeah. Don't move from the window. Stand up right there, so we're hearing you. Go on, honey bun, please. Yeah, hear you.
CXC results. Can't we just do ours? You hearing me?
I'm hearing you. All right. So what it is that you're saying is you're saying that it is, if you couldn't just do the exam in December, that's what you're saying, right?
Yeah, and who start whatever time.
All right. Fair enough. Fair enough, honey bunches. But one of the things I will say to you, without laboring the point a bit, is that to run two separate sets of examination sessions is going to really be very rough on the CCCJ. Now, I have been reflecting on it, and the truth of the matter is, I kind of like it. I'm going to tell you why I like it. I like it because it will give me an opportunity to finish the syllabus fully, and we can just spend some time cruising by just working some past papers and working more past papers. So me not working in the past paper question tonight is neither here nor there to me, because I know I'll have an additional, call it 3 weeks, so to speak, or 2 weeks, 2 to 3 weeks in getting an opportunity to just work some questions with you. So really and truly, for me, I like it because I don't have to be rushing and saying, all right, get a plan. I can only do 2 questions on first order differential equations. I can truly get into first order differential equations so that when your calculus 2 teacher catches you for calculus 2, that means you are ready for the first order differential equations. And you don't have to be saying that, boy, Mr. Shan never taught with first order differential equations in calculus 1. So it gives me an opportunity, Nesta, to truly finish off.
You are teaching calculus 2, you know. So I don't know what you're talking about, other teacher.
I have no clue.
I'm to him. You know I'm to him.
I have no clue.
You try to make sure say that by my time to calculus 2.
I'm going to migrate to United States of St. Catherine. Anyhow, let's go. So
You are our head of school.
Excuse me, say this again.
Who should we write to request you? Our head of school?
Right, Jesus. Pray and ask him. No, me serious too. Pray and ask God to give Mr. Shan the strength and the energy so that he can continue working and teaching and have the vibe, because you know this COVID took no photo away, and then we should be fine. Real talk. All right. So students.
Sure.
So yes, honey. Go, Nestor. I feel your discomfort, Nestor, but go ahead. Go ahead, hon.
Sir, it's very excellent to bring this semester into the next year, you know, sir. It stress me out completely.
Yeah. Yeah, I hear you.
I understand what you're saying, but for not a good look, I like to leave the past into this. Yeah.
All right.
Sir,
Okay.
it's going to stress out us as the evening students because we're basically not going to get any break.
Okay, very good. No, you hit the nail on the head, Charlene, and that is going to be my greatest concern. But put it this way, and this is what I'm going to guarantee you: I'm not going to be quote unquote saying, okay, because I'm not going to have a class tonight. No, Mr. Shan is going to continue coming to class. So I am going to try as best as possible to still finish the syllabus as if we were doing the exam in December. I don't know if you get where I'm going. So now, Christmas is my favorite time of the year, and hands down, me want all if me now go eat the whole heap of Christmas food, but it's just I need my break, and I did not get any break at all for the summer. I did second semester, and the summer semester started a week later while I was still marking. So when I was teaching summer school, I was still marking exam papers, and then this semester started, and I did not get not even a 1 week break. So guess what? I'm just praying for strength, because members say Sir is going to take his 3 weeks break in December. So what I want to have happen with you is that I will still communicate with you guys, and I mean, all of yesterday I was worried about you guys. Jesus, what's up, gone? How am I going to talk to my students, right? But the truth of the matter is, I will ensure that you get your break. But you have to promise me that in the Christmas term, when you get a Christmas break, that you do a little one question. I mean, now say if you go study hard enough, but you don't want the information to miss you.
Sir, rum.
Same way, Saran, rum, right? So you do your stuff, and then come January now, when we hit the road running again, I'm supposed to be hitting the road. Okay, differentiate this for me. Integrate this for me. I want you to do first order differential equation on that. I want you to find a piecewise function, and you know exactly what I'm talking about. And you can just run the stuff, because we're going to the exam. We're going to do very well on the exam. I can mark your papers quickly, and then we get ready for your next set of courses. Yes, Charlene, the only concern is you're not going to get any break, but guess what? This too shall pass.
Sure, it's not the Christmas break I'm talking. Is that
it's a break between the semesters?
The summer and second semester and summer, and then summer and the new school term.
The new school year, yeah, man. Same thing with this, Charlene.
We finished our exam like the Thursday, and then the following week it was school again.
School again, yeah, I know. But as I said before, dearest, I still not finish. I still don't get even 1 week break. I really would love a little 1 week break. And I said to myself, you know what? It is what it is. The pandemic has shifted a lot of things out of whack. I shifted a whole lot of things out of whack. Anyway, I don't want to keep you too long. The only thing I'll say to you is, I remember when I was in high school and used to, go overseas for my summer breaks. And, because we didn't do nothing, when I came back to Jamaica, I was very hot. I mean, I perspired a whole lot because I was in a different climate. So my body was trying to adjust to it. Now, could I wake up in the mornings to go to school? I couldn't wake up because of the time difference and because I was accustomed to be sleeping late, not because of summer. So I had to readjust my body. I'm saying this to say to you that the readjustments will come, but you'll be fine. Just do some work. Anyway, I'm closing now because it's now 4 minutes past. Don't want to keep it too long for the other class. Remember, a question a day will take the pain away. If you're not understanding and you don't do no work, it is going to be difficult. A question a day will take the pain away. Have a wonderful rest of your evening into your night.
So remind me of your phone number.
330-7311.
Thank you.
No, cool.
Same to you, sir. Bye.
Bye-bye. Take care, honey.
Bye. Thank you.
Come on.
Bye, sir.
Bye-bye.